Hi, this is Prasanna from Wave Academia. In this video, we are going to see about how to simulate bridge rectifier model using Matlab. Straight away, I'm going to the simulation. Actually, the rectifier is a circuit which is used to convert AC signal into DC signal. Different types of rectifiers are available: half wave rectifier, full wave rectifier, bridge rectifier. But in this video, we are going to discuss about only bridge rectifier because the efficiency of bridge rectifier is very high when compared to other models. So as I said earlier, rectifier is a conversion of AC signal to DC signal. So I need a AC voltage source as an input. So how to get the elements is I'm going to library browser. So there, go to Simscape, under that electrical, go to specialized power systems, go to sources where you can find AC voltage source. I'm going to pick this one, and then I need, since it is a bridge rectifier, I need a detailed thyristor. Okay, so I'm going to pick this as a switch. That's all. So if you look at this thyristor is having four terminals. Actually, anode, cathode, and gate is there. And one more port is there, M port. I don't want this M port. Actually, this M port is applicable only for if you want to measure the current through the thyristor or voltage across the thyristor. You can use the M port. As of now, I don't want this M port. So I will disable this M port. Fine. I want four thyristor because I'm going to develop the bridge rectifier. Okay, here I will name this switches like this. Say this one is S1, this one is S3, this one is S2, and this one is S4. So now I'm going to build a bridge first, and then I will do the connections accordingly. G to G is connected, sorry, A to A is connected, and then here K to E, similarly here K to E is connected. Now actually this part is nothing but your bridge circuit, which contains a 4 SCR, which is connected in such a way that it forms a bridge. Now the input source is connected with the terminal accordingly. So I need a filter capacitor. This one is nothing but my filter. Okay, so I'm going to use only a capacitor, and then the next one is my load. Here I'm going to use RL load. I'm going to measure the voltage across the load. If you measure the voltage across the load, that voltage will be, it's actually that voltage is a DC voltage proportional to the applied AC voltage. So here I'm going to choose only RL. RL load. Values and all I will let you know later. If you use filter, this bridge rectifier will give you continuous DC. Suppose if you didn't use any filter, actually the output of bridge rectifier is only a pulsating DC that will see at the time of simulation how actually the system is working with filter and without filter. Okay, so here I want to trigger this gates of S1, S2, S3, S4 accordingly. I need a pulse generator. Okay, because it is a switch. So I have to trigger the switches alternatively. At one particular period of time, I have to trigger S1 and S2. At the same time, I have to instruct S3 and S4 to be in off condition. Suppose S1 and S2 is in on condition, means at the same time S3 and S4 will be in off condition. Suppose S3 and S4 is in on condition, at the time S1 and S2 should be in off condition. So this is the way we have to trigger the switches. So accordingly, I'm going to generate the pulses. I'll generate the pulses here. I'm going to use go to tag. Okay, so inside the go to tag, okay, first I will connect it, and then at particular period of time S1 and S2 is going to be on condition. At the same time S3 and S4 will be in off condition. So I want to invert the signal actually. Okay, so I'm using not operator. I'll fix the icon shape as rectangle. So this is also I'm taking one more go to operator. If you want to name this, if you want to tag the operator, click on it. Here you can type this is for S1 and S2. So tag visibility should be global. Actually you cannot use any space. This is for S1 and S2, S1 underscore S2. So my tag visibility is global. Apply it. Similarly, you can tag name it. This one is for S3 underscore S4. Actually, this is for S3 and S4. Tag visibility should be global. In this case, you can use local, but if you are using any subsystem, in that case, you have to use the tag visibility should be global. Then only you can able to access the inputs and outputs and access the signals. Okay, so you should be very careful about that. Now I'm going to make a from tag. So from the S1 and S2, you can easily connect this with S1 and the same tag will be connected with S2. Okay, and then similarly, you can use from tag corresponding to that go tag S3 and S4. Similarly, connect it here. If you want to flip the icon, you can use Ctrl plus I. S3 and S4 is connected with the S3, S4 switches accordingly. That's enough. I think now it is clear. Fine. So I need a power guide that will act as my solver configuration. So in this power guide, I'm going to use a discrete power guide with the value of 5 e power minus 5 as my sample time. Okay, fine. I'm going to modeling. So I will do some parameter changes in my model settings. I'm going to solver details. I'm going to change the maximum step size as 0.01. It will give you the better results. Now I want to see the output, so I need a voltage measurement. So first voltage measurement is connected with the input, and then I need one more voltage measurement because I want to measure the voltage across the load. So now we can easily compare the input and output voltage with the help of scope. I'm increasing the number of ports as 2 because I want to compare in a single scope. So now the input is connected here and output is connected here. That's all. Okay, fine. So in this manner, you can easily develop the bridge rectifier model using Matlab Simulink. First, I will tell you what are the inputs, the values I'm going to give. Discrete, I'm going to use a discrete power guide and sample time is 5 e power minus 5. And the input voltage source, for an example, I'm giving 15 volts. I'm going to convert this 15 volts AC signal into corresponding DC signal, and I'll use 50 Hz as the supply frequency. Okay. Now you need not to change the thyristor parameters. It's not necessary. Here, go and change the filter value. I'm going to use 50 e power minus 2 farad. I'm going to use this is my filter value, and similarly RL value, my resistor value is 10 ohms and the inductor value is 100 microfarad. Apply it. Okay, my filter value is 50 e power minus 2 and RL value is resistance is 10 ohms, inductance is 100 microfarad. And then I'm going to pulse generator. I have to generate the pulse. I can say that my amplitude is 1. Let it be pulse type is time based. Amplitude is 1. Period, I'm going to change this as point not 2 seconds. And then you can fix the pulse with this 25 percentage. Okay, let it be phase delay is 0. Okay, no need to change the phase delay. Apply it. Okay, now go to simulation. Now if you run the system, you will get the DC output. The AC will be converted into DC. If you look at this, I'll expand it, then you can get to know. I'll zoom it. So now you can get to know that this is your AC signal. That AC signal will be converted into continuous DC signal. Okay, so it's a continuous DC signal. So now the bridge rectifier operation is done. as per the requirement. What will happen if you didn't include this filter? Okay, I'm just uncomment this one. I'm commenting out. That means I'm taking this filter out from the circuit. So it won't create any impact on the circuit. This capacitor won't create any impact. Now if you simulate the circuit, so what you can came to know, actually this is also a DC signal, whereas this one is AC, and the blue one is actually it is a DC signal, but it's not a continuous DC, it's a pulsating DC. If you omit the filter, the rectifier will give you only the pulsating DC. Once you include the filter circuit, what I'm doing again, uncomment it. Now if you run the system, now if you look at the system response, you'll get a continuous DC. The blue line is the continuous DC. So from this manner, you can easily understand what will be the usage of filter in a rectifier model. Okay, so hope this circuit will be helpful to you to develop the bridge circuit using Matlab Simulink. Thank you very much. Kindly subscribe to the channel videos. Thank you.